Well, hello everybody, and if you're wondering who this is and don't know the voice, it's me, Albones. And I am currently in a different avatar because I'm on Rosedale, the US Army's Open Simulator project. And we've just been treated to a very interesting Q&A by Philip Rosedale, no less, about his new venture, High Fidelity. Although slightly technical in places, it's in very understandable language, and so we're going to bring it now. Enjoy.
Thank you very much, Douglas, and thanks everybody for taking the time to come and listen. I really appreciate getting a chance to tell this group a little bit more about what we're doing with High Fidelity. I see a few people I know, which is fantastic, that I haven't seen in a while, Mal and Amy. And I apologize for my very basic looking avatar. I still need to kind of get dressed. When they switched me over to Philip Rosedale as opposed to Philip Linden, I got demoted in my avatar appearance. And thanks Chris Collins, who's sitting next to me here in San Francisco and can help me with slides and whatnot. So Chris also collected questions from everyone, and I tried to take a crack at sort of pre-answering them, and I'll do that first, and then first I'll give you guys what is hopefully a helpful overview of High Fidelity in comparison to Second Life and to OpenSim. And then also I'll try to answer the questions that were sent along, and then you guys can ask more questions. And certainly, we can do those in chat, and I can, do the usual chat and fast verbal answers back. So again, thanks for having me. It's great to have this group. It's an honor to have you guys take the time to hear a little bit about what we're trying to do. So let's jump right into that. So the first slide that we put up, Chris went and took a picture of our old, here in San Francisco at the High Fidelity offices, which of course you're all welcome to visit if you're out here. We're 7th and Folsom, so we're downtown San Francisco, not too far from the historic Linden Alley office and the current Second Life office. But we're having a great time, and up on the wall we've got that image that's the first slide there, which is of the original Second Life architecture. This was a Visio diagram that I made in 2000, and so it's kind of interesting to look back on it and take a look at what we kind of did and didn't get done. If you look at that diagram kind of in the lower left, I wish I had a laser pointer, easier to do in High Fidelity, but I could point at that in the lower left there, or sorry, in the lower left of the green or middle band there was an item called the proxy, which I think kind of relates to some of the great work that's been done here with extending OpenSim to larger audiences, and also speaks to kind of what our original plans were with Second Life versus what, as things started to take off, we ended up being able to do. And that was the sort of proxy there that was the original idea that we had kind of on the napkin around Second Life, was that there'd be some sort of an intermediate layer of machines which would stand between the simulated the simulators, the simulation of the virtual world, and then the audience of people that were interacting with it, and that would enable us to get more scale. But it's kind of funny to look back when I found this diagram, which was in my garage for a while, and looked at it. I realized, oh, it's really interesting that we actually had a component, the proxy, that we ended up not building. Just because we didn't have the time, and we got things up and running and kind of just did without it. And it's interesting as we look at High Fidelity now. It's interesting to kind of, in a sense, almost look at a lot of the High Fidelity diagram as being the answer to the question of building that proxy. So let's kind of switch over to that, and let me give you just a brief overview of what we are kind of trying to do, and maybe also I can explain sort of what we've built so far and what we haven't built. So this diagram here is the main system diagram for High Fidelity. The gray band at the top, called Global Services, and the sort of contributed devices and agents and objects blocks, represent kind of the pieces that we as a company hope to build. And then the domain server, the internetworked virtual worlds and clients blocks down there at the lower left, middle and lower left, are the pieces of the system that are open source and that we hope to make the best implementations of. But our thinking is that this next generation of virtual worlds will require a simple, stable, worldwide open source system that has an understandable set of simple servers that allow people to create virtual worlds and then internetwork them. So kind of let me take a look at a bunch of these kind of pieces and hopefully give you some ideas on what we're doing. So you can see that thing, the domain server. The high fidelity idea is that we first build, we really thought of like Apache as being a good model for high fidelity, and we think of the domain server as being a little bit analogous to your basic Apache server. That is, a virtual world should be as simple to set up on a set of machines on a server, or on your own laptop if you want to run one locally, as we do. It should be just a very easy to run process that starts up and that kind of feels like a web server, where this process fires up, basically provides you access to a basic virtual world, and then has a bunch of settings that allow it to deploy actually a hierarchy of other machines beneath itself, basically in a tree-like diagram, which is what you see in the diagram there, where the audio mixer, avatar mixer, and voxel server is displayed. The domain server can set up a variety of other sub-servers that are actually streaming the data that is inside the virtual world to a person who's represented by the interactive client circle there at the bottom, who's also connecting to this whole thing via an open source client. So the domain server sets up these servers and turns them on and off, and maybe remembers what files are associated with their content, and then the interactive client gets access to that content. And obviously, as you've probably read about, on the experience side of things, we've focused on making these small, lightweight processes so that two very different types of scalability and performance come out of the system as compared to Second Life, by example. The first is that the total latency between any two users that are sitting in the world together, like we are here, should be fairly low. Our design goal is to get everything down to less than 100 milliseconds. So from the moment I move my eyebrow or make a sound to the moment when you hear it or see it should be less than 100 milliseconds. And the way we achieve that is by deploying these small servers underneath that domain server, which are ideally a single point that stands between two interactive clients. So when I speak in high fidelity, my voice is being transmitted as a 24 kilohertz uncompressed audio stream up to an audio mixer, which is spatializing it into 3D and then making a separate receiver mix for each of the people that is standing near me that's listening. We are trying to do that quickly enough by slicing up the audio into small packets, 10 millisecond packets in the example of our audio today, that the total transit time is very small. The actual network and transport time is more on the sort of 30 to 40 millisecond range. That is sort of 2 frames of buffer, 10 milliseconds. And then most of the buffering, most of the actual end-to-end latency we see today results actually from the operating system buffering at the two endpoints. And I mean, that's true for audio, true in a different way for rendering and things like that. So we're basically trying to build a very simple low latency transport that mixes data together about the people that are standing in the virtual world. You can see there that the audio mixer kind of has a hierarchy, a multicast tree underneath it. Our design here is that as either more content or more people come into a domain, these machines can be dynamically allocated from a pool of available machines to increase the scalability. We've experimentally determined that we can mix, and I think this fits with sort of bandwidth requirements and things like Amazon's EC2 and things of that sort. You can mix about 100 people together with 3D audio on one machine. If you assume that those people are getting about a megabit per second of audio, let's just say, you can imagine that you might be able to serve 100 people or so off a machine before you're, practically speaking, going to run out of bandwidth at any one sort of endpoint. So we've built the idea that as more people than that show up at an event, we essentially dynamically assemble a multicast tree, creating additional machines as shown in the diagram there as necessary to handle the number of people that are all standing together in world. We do the same thing with avatars. The avatar mixer as shown in that diagram is the thing that's taking your orientation, movement, facial expressions, body joint rotations, and anything else about the avatar, mixing them together again and creating a stream that can be sent to everybody else that's standing around. The voxel server is a kind of a container statement. I'll touch this later on some of the questions that were asked. We're not trying to build a world with voxels like Minecraft. I'll get to that. We're using a spatial oct tree, which is a subdivision scheme where we can efficiently represent what's in a virtual space on a server in a way that enables quickly streaming the interested set of data that's near you to the people that are in the virtual world. We use this concept of a sparse voxel oct tree where the world is subdivided into smaller and smaller cubes according to how much content is there. And that's what we're doing. So that's what we're doing in High Fidelity. So that'll enable us to scale the other part of the equation, which is what do you do if you want to put a terabyte of mesh say, for example, content right where we're sitting right here. Well, what happens in that case is you're going to have to store that data efficiently so that it's obviously kind of only accessed and transmitted to somebody who's very close to it. And as they get farther away, they don't get the information. The use of a sparse voxel oct tree is basically the architecture that we've chosen for Hi-Fi, and we think it's the right architecture. It's also the architecture that some of the big gaming companies are, thinking about with respect to more literally how you render very complex data sets in worlds. So that's the idea of the voxel server, and I'm come back to that more with the Q&A. The other big thing that we're doing that you can see over there on the right is we're creating the opportunity to potentially assemble the machines that you need to scale from other people's contributed devices. And there's been a bunch of good questions about this in the QA, and I'll come to that, reread them, and then answer them specifically. But the basic idea is that we hope to provide a very sort of SETI or BOINC, to use the actual name of the service that the SETI service is actually deployed under now, I believe. We want to create a very sort of SETI-style system in which anyone can contribute devices that anyone else potentially, if they want to let each other do this, that anybody else can use to extend their domain in the manner that I just described. So you can see those little dotted line arrows coming from right to left. That's different contributed devices being assigned from High Fidelity to serve as small servers that extend the capabilities of your virtual world. The other way that the virtual world, the other really interesting thing that we're doing in that regard is, and you can see this down in the lower right there with scripted agents and scripted objects, is we're using JavaScript as a general purpose language to allow you to create interactive content in the world. An example would be a flock of birds that are flying around, encircling our heads here. In that case, what happens is a domain server can allow an assigned server to run a piece of JavaScript and log into its own servers and then, create some sort of interactive content. So the basic way that you can see this being very exciting from a scalability perspective is lots and lots of people around the world can basically donate their machines while they're asleep to do something like be a virtual pet. So that machine could get assigned to run around as an animal on somebody else's domain. And the idea there is that the domain operator is going to pledge to give a small amount of a new virtual currency, actually a cyber currency, to the person who's donated their machine. So this example of kind of like really interesting complex scripted objects, I think, is a good one that really ties back to Second Life. Obviously, with Second Life and with OpenSim, the simulation, the physics and the scripting simulation of the virtual world is often running on the same machine that's doing the streaming of the data to end users that are standing there. this is problematic because it's obviously very easy to write highly complex scripted content that blows through the capabilities of those simulation machines. So you'd like to separate those two out into separate machines, and that's exactly what we're doing. And we've got that working today in Hi-Fi pretty well. So we're already paying our alpha users little bits of virtual currency to use their machines to do things like playing the game of life, which I think is all we're really doing with them right now. We have them basically playing voxel versions of the game of life over in the corner of our alpha region. But we've demonstrated and gotten to the point where we know this works. We know we can make it work, and we're pretty happy about the overall architecture. So I think that's most of the kind of core architecture. Obviously, touching on that global services layer, which is the upper layer of the diagram, our hope is that as a business, the services we can provide that'll be useful to people and hopefully we can make money from providing are these optional set of services up at the top that will basically allow people to interconnect themselves and their content between these different open source virtual worlds that they create. So the name server is the idea that you might want to globally name a place like San Francisco, as a string, or Chris Collins as the name of a person. And if I just type, at San Francisco when I'm in any virtual world in which I'm using sort of a standard client to access, it's gonna ask High Fidelity's global services what server is San Francisco, and then it's going to redirect me to that exact place and orientation in the virtual world. And that's something we hope we can actually charge people money for, probably in a manner very, very similar to how like VeriSign charges or Network Solutions or a top-level provider charges for domain names today. Moving from left to right, the digital marketplace is obviously something else, as you guys all know, is important to be sort of managed in the correct way. And the idea there is that obviously if you buy, attachments for avatars or avatar clothing or avatars or objects or anything else, and you want to move those around between virtual worlds, our belief is that we can provide a set of services. Well, first of all, we can provide a marketplace where people can use the virtual currency, perhaps the virtual currency they earned from contributing their machines, to purchase digital goods in that marketplace, in a single large marketplace. And then as they move around from machine to machine, we're going to move those goods around for them. I guess that's kind of similar how how we use the asset servers to move things around between simulators and Second Life today. It's also similar, I think, to some of the really cool work that's been done with like the hypergrid and other sort of extensions on top of OpenSim that seek to provide interoperability between those machines. So we agree that kind of having avatars, names, identity, and content be movable around between these various worlds is another critical part of the design. So our hope is that we can provide a good version of that as a company to you. And you won't have to use it because, of course, this is open source and the domain server doesn't have to connect to global services at all. I guess the example of a government or a military simulation would be a really good example of a case where you may well run the open source software that we're building completely in isolation, behind a firewall with your own user accounts if need be, in a manner where it's absolutely, completely disconnected from the real world because it has to be. But obviously many of these virtual worlds we think people will want to interconnect, and so if we can do a good job of providing the namespace and the marketplace for that interconnection, we can be successful that way. So that's kind of an overview. I'm looking at Chris to see if I missed anything, but that's kind of a basic overview of the high level architecture, if you will, of High Fidelity. And maybe now I could just take on, I'm going to rapidly go through the questions that that Chris collected for us for today, and then get to what other questions you guys might have. So Chris is nodding at me, so I think I'm doing this okay. So I'm going to jump right into that now, the QA. And I try to group things together, so forgive me if I didn't do this well. But the first thing I'm going to talk about is generally about the economy and the assignment clients and how people are contributing their machines. So a couple of questions. Address concerns of people willing to leave their computers online and running to contribute to the processing farm. And then some more specific questions. This from Gwinnett Sinclair. And that was, how will the sharing processing power actually work on the gear end? Are there ISP bandwidth minimum speed requirements, and will a user be able to set a limit as to how much bandwidth is shared per month? That's a great question. here's what we're thinking we're going to do. So what we use today is an assignment client. An assignment client is a general purpose sort of subserver that runs on your machine. Hopefully we'll just install it with our client. I think we install it with our Mac client, not with our Windows client right now on High Fidelity. But the idea is that the assignment client will be a simple utility that you'll run on your computer, very much like the Boink client in the example of that network, and I'll get to that later. When you run the assignment client, you basically are going to be able to set a bunch of parameters about what you want it to be able to do, and then you're going to let it run. And it's going to pick up jobs like I discussed from that diagram, and it's going to go do those jobs for other people, and then you're going to get paid in a cryptocurrency for the compute time that you delivered. Now, with respect to things like bandwidth, yes, what we'll do is we'll put some settings in so that you can set things like your peak bandwidth use that you'd like to hit, and then aggregate limits. Like when I'm looking at Chris Collins, who's originally from Australia. I remember when we got Second Life running initially. I remember we ran into the fact that there are countries around the world where there are these strict upper limits on bandwidth, monthly bandwidth for different ones. What I suspect we'll do there is we'll put in a setting where if you're running an assignment client, you can set the maximum amount of bits that you want to deliver over a time period and then not go over that, which would mean your assignment client would stop offering its services to the network once you'd reach that limit. And then ditto with respect to peak. On our side, we're going to do sort of SLA and QoS statistic collection on the nodes, that is the devices that people contribute to the network. So we'll be able to also measure and share share with the people that are using the computation marketplace, which is basically another word we use for our this idea of assigning your machines to various other people's machines. What I think we'll do is collect a bunch of QoS SLA stats, and we'll probably just make those highly transparent. So like everybody can see what people's nodes are doing in terms of packet loss, bitrate availability, how much time they typically have their machine online, how much notice you need to give them before you take before you basically shut down your client on their machine, things of that nature, and then let you, as a consumer of that computation, like if you're a domain operator, as we call it, who's buying computation from other people, you'll be able to set what requirements you have on things like latency, end-to-end delay. Like obviously you might not want to use a server in Singapore to do audio processing for people in California because it's going to add 90 milliseconds of transit latency. So we'll collect all those stats, make them visible to other people, and again, this is where we'll hopefully do a good job and be able to make money, probably by charging some fee or something for these assignments. So we'll collect those stats, but you'll definitely have the ability to regulate what you can do. Steve Lavigne, I hope I'm saying that right, said, will it be main CPU cycles or graphic CPU cycles shares or both? Right now we're doing CPU-based assignments with the assignment client, but we definitely imagine adding GPU style assignments. There's obviously more development work in that because the GPU environment is so different on different machines, especially on Windows. So we've got to figure out a really safe way to, qualify what the graphics coprocessor can do. But the manner in which we do assignments, it will definitely be amenable to using the GPU. For example, one of the assignments, and when I use assignment, I mean a job basically that we figure we can easily farm out to other people's machines. One of the assignments that we'll be doing is like relighting. So imagine a scene like where we are right now. This scene could have like really, really beautiful global illumination and shadows and detailed lighting for all the static content that's sitting in it. That's an example of a job that can be done by somebody else's machine, so that every time the content is changed, somebody's machine jumps in there and basically relights the whole scene really beautifully. And that's something that we think we can do. Hang on a second, let me look through this. And then compatibility with different operating systems and hardware devices, also from Steve. Well, the system is open source, so we hope we'll get onto as many devices as we possibly can. But addressing that more specifically for a couple of examples, we think that, our code today, the Alpha High Fidelity code, runs on Mac, Windows, and Linux. It runs worst on Windows right now because we haven't had any Windows developers actually in-house. we're just starting to kind of climb that hill and get better at doing Windows. Just by chance, we all kind of here, and being in San Francisco, we all ended up using MacBook Pros for everything. So High Fidelity runs best on a MacBook Pro, but we're obviously going to rapidly come up to speed on Windows, and it does build and run on Linux as well. We have a couple of folks here that use it that way. An important note about OS and device compatibility in general, our plan is that for basic looking into the virtual world, for like looking into somebody's domain, our plan, and we haven't done this yet, but our plan is to also make all the viewing of the world HTML5 WebGL compatible, especially for the basic viewing case where like we don't need to log you in as an avatar, or you don't need to say use a motion capture suite or something like that. You want to just look into the virtual world. Our thinking there, to the extent that we understand the architecture and the capabilities of modern browsers, is that we definitely should be able to do a 30 to 60 frame per second great job of looking into the virtual world just over, WebGL, that is HTML5, so that, everything except for, I guess, the latest version of IE or whatever should basically be able to look into the virtual world just with a browser, without client software at all. That's our vision, is that basic browser access is a very compelling way to get into the world, and then deeper, more interface enabled access, you're almost certainly going to download a client, because why wouldn't you? It's always going to be somewhat higher performance. Jumping down to security, I just saw some questions from Doug about that, and we can come back to that, but hopefully this will wrap in some of this. Mark Sturgill, we're asking, what level of security will be offered for the files on the computer sharing resources? That's a great question. I think one of the reasons that we even think we can build a really big shared environment for allowing tons of people to share resources is kind of that we can get around some of the more strident security problems that you have when you're just looking at generalized computing, and instead consider the sort of smaller space of problems and different set of possible solutions that you can use in a virtual world. So a couple of things about this. The first thing is, the most important thing, just practically speaking, is a domain operator, a person running a high fidelity virtual world, can restrict, of course, the machines that they're running on. And part of our other vision is that you can request machines from a pool of machines where, for example, those machines are, say, all behind the firewall with you. So one of our very high level statements about security is perfect security is never possible, and sometimes people just care about a particular approach to security that's more psychological than literal in implementation, and we have to provide support for all of that. So if you want to run high fidelity completely behind a firewall using machines that are all behind the firewall, that absolutely will work. So that's a first statement, a zeroth order statement about security. In general, there's this sort of man in the middle problem, which is if you trust someone to simulate part of your virtual world, you can never have perfect security around the data that they have access to, because of course for them to be able to simulate the world also means that they need to be able to see it. And so our thinking and belief is that there's no way to break the simulation of the virtual world down in such a clever way that no one helping with the simulation knows anything about what they're doing. We believe that's a kind of an NP complete situation where you couldn't actually do it that way. Now, what we believe, though, is that for most people doing most simulation jobs, here's what will probably work, which is basically security through redundancy and obscurity. And let me say what I mean by that. So one thing is, if we as a parent company control the allocation of jobs between different people that are offering their simulation, provided we stochastically or randomly allocate different people to different jobs, and provided we generally obfuscate the relationship between a job and the machine that's being assigned and the machine it's helping, which of course kind of falls out of the way the internet works anyway. That is, when we give somebody an assignment, we're not going to say, you're assigned to go simulate Philip Rosedale's backyard. We're instead going to say, you are going to relight the domain segment found at the following address. And so part of the thing there is that unless you've done a really good job of, remembering the content that you're looking for and want to have, illegal access to, so to speak, you aren't going to be able to discern that in all likelihood, because there's going to be such a large number of participants' jobs and, again, random distribution of jobs, that it's very unlikely. So in a manner similar like to Bitcoin, proof of work, it's very unlikely that you would get so lucky. You'd have to spend an enormous amount of time to get access to a very small amount of content, basically. So we believe that this concept of just randomly assigning jobs to different machines and then using the right high-level description that doesn't identify a priori, for example, what content you're going to compute, provides an appropriate layer of security for a lot of jobs. As I said, touching on that zeroth order thing, if you don't like that, you don't have to use the network. The other thing is that we're going to do a lot of as many assignments as we can do redundantly, we will. Both because it'll create a failover opportunity, but also because, again, as the assigning marketplace, we can compare the outcomes that we see on similar jobs and make sure that nodes are redundantly generating, without knowledge of each other, the same output. So that's another interesting thing about security. If we worry that somebody might be, say, manipulating the content in somebody else's virtual world just to be a jerk, we can have the virtual world content manipulated by two people who almost certainly don't know each other because they were chosen randomly, and then compare the results. Or three people, for example. And if we find two people generating the same result and one person generating a different result, we know that one person is probably a bad actor. So we're gonna take that kind of strategy. I have to say I'm hand-waving about some of this because we've not yet developed all the code. But if you take a look at what we've done so far with High Fidelity, you'll hopefully be impressed and convinced that we're going to get there. We're moving pretty quickly. And thank you very much, by the way. I'm reading the chat and loving you guys are summarizing it better than I could describe it, so I'll probably steal some of your expressions there for my later conversations. Yes, end source voting and checking for disparity. Totally. I would make the general observation that, by the way, that stochastic assignment of hash-style jobs like relighting, in which you can verify that the output had to be unique and was unpredictable from the input, is a very interesting alternative to this sort of Bitcoin proof of work idea. It's just kind of as a side note for those really into all this stuff out there. It's fascinating to note that you can compare the known work of two people to establish that they both did something hard because it's identical. I've been struck by how cool that is in comparison to the smaller set of things for which you can do like reversal of a hash and prove that something happened. Somebody had asked a question. So moving on, somebody had asked a question about sort of BOINC versus Hi-Fi mind modeling. I think was, and I'm sorry, I don't have the person who asked that question's name written down here. Yeah, obviously the big challenge we're trying to solve compared to a distributed job system like BOINC, or even, I guess, more abstractly, something like Hadoop, or the general problem of distributing compute assignments amongst multiple machines, is that in the case of the virtual world, we almost always have a live low latency requirement as well. So we're not just assigning a job that can be packaged as a set of inputs and an algorithm, and then we expect an output. But instead, we're basically trying to build a marketplace that assigns live machines where, a lot of the exercise is packets being moved around between one machine and another machine in real time. The literal example of scaling an audio broadcast like this to 1 million people, which we think we're going to be able to do with High Fidelity, is an example of live allocation of about 10,000 other machines arranged in a tree to kind of multicast, to effectively multicast, or sort of proxy multicast data out to a lot of people. That's just like not really a compute assignment at all. It's basically a real-time broadcast assignment. So the big difference, I think, between what systems like BOINC have done and what we're doing is that we have to, and are therefore creating a different architecture around solving the live low latency case for distributed compute. I bet that was obvious, but maybe for some folks who haven't looked at things like BOINC here, there's a rich history of really good systems that do distribute jobs on the internet amongst machines, but we have a harder problem here that we have to solve, which is to distribute live transit, basically, amongst machines as well. So the next area was somebody talked about explain the mocap or motion capture aspects of high fidelity, and then there are several questions that are grouped together here. That one was from James Stibbards, and then Gwinnett had asked, give a list of the type of gear one needs to take advantage of that mocap. So let me pull all that stuff together. Oh, and then Gwinnett had also asked, can you do the mocap and Oculus at the same time? Short answer is yes, but let me outline what we're doing. The body of the avatar in high fidelity is a set of fully articulate joint rotations all the way down to the tips of the fingers. Or actually, sorry, any skeleton can be animated. So you're going to be able to build a skeleton of an animal or a skeleton of a person or whatever. But basically, that skeleton is transmitted as your avatar, and it's articulated as joint rotations. So what does that mean with respect to motion capture? Well, and of course, that's all also sent at the avatar mixer runs at nominally 60 frames per second. So on a good day, we can take the joint rotations from a live motion capture device and get them out to everybody that's sitting in the audience here within a 60th to a 30th of a second. So it's very, very low latency transmission of joint information on arbitrary skeletons. That's kind of the high-level technical statement. What gear do we provide support for? Today, we've already got working the Hydra, which is the Razer Hydra system that is a hand controller system. So we basically animate the avatar's body to follow your hands. We also have the Prio VR system. We've got the first couple of alpha units of that, and we have that working. It's amazingly cool. It's basically a very low-cost inertial capture system that tells us the rotations of the body parts, and we basically take that and transmit that to everybody else. So basically, you can see somebody jumping around or dancing, and you see their whole body moving. Chris was rigged up in this thing for half the day down at the SVVR conference, and it's completely wild to see somebody moving and then see their avatar on screen mirroring them full body with relatively low latency. We anticipate support for the STEM device from Sixense when it comes out in the next couple months. I bet we'll have that supported instantly as soon as it's out. We're in close contact with those guys. That should be very much like the Hydra, but with much more accuracy and lower latency. The Leap, we implemented the Leap controller, which is a video-based thing that detects your hands over the keyboard. The first version of the Leap was really, really hard to use in a VR environment because of the way it enumerated the hands. The second version of the Leap, though, is extremely compelling, and we're getting it integrated right now, so we should have that in pretty soon. Things like Control VR and the several other projects that are coming out to give some sort of cheap combination of body and hand capture, we'll work with all of those. Got a call with the folks at Control VR later today. I mean, it should be very straightforward. So anything that does this kind of inertial or magnetic position sensing, we should be able to kind of staple that data onto your avatar in real time, and obviously that's a big piece of our wow factor, what we think is going to be so different about high fidelity. You didn't touch on, but I think you were asking about like facial capture and stuff as well. In addition to the Oculus, we optionally use 3D or 2D cameras to capture facial expressions, and the really neat combination is actually the one that I love is like using the phase shift with the Prio at the same time. So that lets you do something like play live music where you're singing and your face is being captured very well, and your body is also being captured. So you can use all these things together or separately. The only thing you can't do, obviously, is use an Oculus and use something like phase shift to capture facial expressions, because the Oculus is blocking your face from the camera. But we know the folks at Oculus are looking at things like what can you do with the eyes inside the device, and can you do anything with the mouth, and there's obviously going to be a bunch of different solutions here. I personally think that the virtual world is going to have people that are acting sort of more as performers or actors that are using some of these really cool devices, such as the 3D camera. And then the people that are using the Oculus, I think, are going to be more the casual kind of, oh my God, observers of all this, or the audience, that's enjoying the experience. Next question was, what are the plans in the areas of e-coinage and virtual world currency? Well, I touched on that a little bit earlier. Basically, what we think is that we will probably, like in things like this assignment system that I mentioned, where you're getting paid basically to help other people out with their compute cycles. What we'll be doing there is technically is managing wallet balances that are tied to a cryptocurrency. The cryptocurrency, we're still thinking about whether we use a side chain or we use our own cryptocurrency or what we do there. But what we're thinking will work is a cryptocurrency behind the whole global system that has transaction fees in it. And has a monetary policy that's a little different than Bitcoin. Our goal is to create a cryptocurrency that has a mildly inflationary automatic monetary policy rather than the deflationary policy that Bitcoin has today. Again, this is going into the technical depths of it, but I bet there's people here in the audience that are interested in this stuff. Our goal is that by not allowing de novo mining like Bitcoin does, we can create a system where the money supply grows automatically, algorithmically, in other words, not through our control, but just by agreement in the same manner as Bitcoin. The money supply grows through GDP growth, which will get us closer to a very stable pricing model like what we've seen with the Linden dollar. The Linden dollar has been much more stable against the dollar than the Bitcoin, obviously. And the reason for that is that Bitcoin is deflationary, and so people are using it as a hedge vehicle or almost a new commodity rather than using it as a transaction tool. So we're going to shoot for something that's more like a transaction currency, because obviously what we want is something that's nice and stable against real world currencies in the same way that the Linden dollar is. The next question was, how will you, and I'm sorry I'm ripping through these, but I want to give time for a bit of Q&A. How will using voxel creations affect the development pipeline versus traditional mesh? The short answer there is, and with respect to build tools at all, the short answer there is we are going to use full mesh. And you can already see this in High Fidelity today. The voxel system is going to be used to represent objects at a distance, and when objects are up close, you're going to have the option. You can build with voxels if you like, very small voxels, but you're going to also have the option of uploading full mesh models from basically anywhere you choose. And we're doing that today and making great progress on it in High Fidelity. You can come in there and see us, loading models in World. So basically, you can imagine taking something from SketchUp or something from Blender or something from an FBX file and just importing it into the world. Our avatars all have attachments and stuff on them now in High Fidelity that are raw mesh models. If you put mesh in the world, what's going to happen is it's going to get stored in a spatial tree as well, and basically as you get far enough away from it, we're going to turn it back into voxels. That's something we think we can do that's incredibly compelling, by the way, because it's what will allow us to create an infinite amount of content in the world, but still see it all at an infinite distance. We just turn it into boxes, basically, as you get far away from it. So we're not thinking that everybody's going to want to build things like Minecraft and remake, the beautiful, incredible world that we see here, like in OpenSim or Second Life, in voxels. We don't think that's going to happen, but voxels are the right way to represent things visually at a distance beyond 20 or 30 meters or something like that. In-world build tools, what we're really excited about is using motion controllers to manipulate like mesh objects or voxels in the world around you using your hands. So what we kind of imagine is that the textured mesh creation will happen in whatever package people want to use. So again, things like Blender or 3D Studio Max or Maya. But then once you upload an object into the world, probably the positioning of it and the interaction of it with other objects will be the sort of things that you'll do with your hands or with the mouse. Doing it with your hands, one of the demos we have working right now that's just so much fun is like I can put a hat on my avatar and let go. I can use the hand controller to I'm doing this, Chris is watching me. Of course you can't see me because we're not in High Fidelity, but I'm pointing up in my head at my head. I can basically take with a Prio or a Hydra, I can put my hand near my head, grab my hat, literally take it off, nod, bow at you, and then put my hat back on again. And when I let go, it reattaches to that attachment point on my head. That's really cool, and we think that something like that where you're using the motion controllers to move objects around in world is what's going to be very cool. That's also the answer to this question that James asked, how do you plan to make this approachable for consumer adoption and non-technical users? I think the way we go from 1 million to 1 billion users in here is by solving this problem of the hand controllers and the head and view controller. That basically 2 degrees of freedom, which is the mouse and the keyboard, is just not enough to both move around and manipulate objects in 3D. And the people that are here, I think of somebody who's done amazing content creation, and well, actually, I won't single anybody out here in the audience, but you've all done amazing stuff, and as you know, the cost of doing that amazing work inside the virtual world has been an incredible amount of learning time. And normal people that only have an hour to jump into a virtual world cannot, using a mouse, master the degrees of freedom translation. But what I'll say from having used these hand controllers in the Oculus is it's a totally different game with the Oculus and hand controllers. If you have the Oculus and you can hold a hand controller or have your hands tracked with the Leap or whatever, you are going to be able to create content in a 3D world and move around and have fun in 5 minutes. And that means we're going to go from 1 million effective users, the scale of the virtual world today being about 1 million people. I mean, I think everybody here would probably agree that's kind of the number, to the billion number, which is everybody that's on the internet. So our vision is we don't have to do a whole lot at the software layer other than solve these scaling problems like I've been talking about, but we've got to just get this hardware on people's bodies, basically. Now, that doesn't mean that people that don't have that hardware won't participate. Of course they will. Everybody here can basically do all this stuff with a mouse and a keyboard because you've gone through the learning curve. Good for you. But what we hope to have soon is a lot more people in here, that didn't have to climb that hill. So with that, let me stop and take a few questions from everybody here, and also say thank you for putting up with for being willing to listen for 1 whole hour there. So does anybody have any sort of text questions to shout out here? Is that what you're saying, Chris? Lisa, ADA compliant viewers, absolutely. I mean, I think that I mean, we're not a big enough team yet to be, formally exploring exactly, telling you that I have a product plan on exactly what we're going to do for ADA compliance. But I think that the nature of virtual worlds in general is that they enable people with disabilities to participate in them far better than in the real world, and that, I believe, will also be one of the driving factors going forward with High Fidelity. And the fact that it's open source means that we're going to be able to get more of those features in rather than less. Touching on that for just a moment with respect to open source, Chris had wisely told me there's a couple of avenues for getting involved in this. All of the code today is on GitHub. You can easily find that, highfidelity.io. You can find the GitHub code. So this is buildable and usable today. You can email me or Chris Collins here. You can get a hold of us with requests to get into the alpha program, and we can do that as well. To the question, how many alpha members are in Hi-Fi today? There's like 100 people that are doing things right now. We're in a very early stage. Lots of our stuff doesn't work. But the people that are really interested in exploring it to kind of better understand how things are going to work in the future are already doing that, and we've got about 100 people that are in there doing things right now. So just a few. The other resource we have is the work list. Worklist.net is actually the system that we built ourselves. So it's part of High Fidelity, which enables us to bid out small jobs and get help from people on doing work. So when you look at something like a particular ADA compliance feature, that's the kind of thing that what we actually do is we write it up in the work list and then we fund it with our own money, but we let anybody else in the community jump in and do the actual software development. And the work list is pretty cool. It's a well-designed system that we put a ton of work into over the last few years, actually, before High Fidelity. And it does a really good job of being a kind of a bridge between the free open source contributions and the whole kind of code review process and pull request process that you see with open source projects. It's a nice bridge between that and full-time employment, where people that are actively needing to make changes to the system or wanting to, but want to do it and get paid for it, or want to do it on contract, can do that. We also believe that we're going to use the work list eventually to actually allow people to run their own projects on it. So somebody might have a project like ADA, where they say, hey, I want to fund, putting $100,000 into doing this big project on ADA compliance, and then it's going to be easy to publicly put that up as a project we've written all the software already to kind of break out the budget and everything separately, and then pay people to do all the sub jobs out of the community. So I think this will be very compelling as we move a little bit farther along. Yeah, Douglas says we'd love to we would love to work with you on the security issues as well, and I'm sure Douglas, Chris will follow up with you on that. And ditto to James. Kurt was asking, in terms of contributed devices, how do you handle a situation where a storm might take out a large number of devices? I guess the meta answer there is, DARPA gave us the internet basically, and we know that it was designed to be to basically route around really large holes in the overall architecture. I think the high level answer there is to break the compute assignments down so that they can be as small as possible, therefore distributed across the largest number of devices, and also as redundantly as possible. Now, not every computational task is as amenable to parallel redundancy as every other, but things like audio mixing, for example, are things that can be done in parallel so that if you do lose devices, you don't get that. And obviously the other hope is that if we can run a QoS SLA infrastructure at the top level that knows where the machines are, we can try to optimistically distribute computation assignments so that parts of the virtual world are being simulated by machines that are in very different physical areas. So hopefully that's a bunch of thoughts on that. And we're going to maybe I have time for one more question, but Chris and I have got to jump off and jump into our own company lunch and meeting here there. Kay was putting out the cost. Kay was saying cost of the Oculus plus the hand controller plus Leap seems like the new, it seems like the ease of use means spending money. High cost equipment reduces use. Yes, that is true. But first of all, people that are willing to invest the time to learn how to do things in the virtual world without that equipment are going to be able to do so, as I touched on earlier. The other thing, Kay, is that frankly, I think we're just at a very exciting moment in history, because I know that Facebook / Oculus and everybody else believes that the cost of these new interface devices is going to be remarkably low. I mean, I know Oculus's goal is to have this thing be shockingly inexpensive. I mean, I don't know whose numbers to believe on this, but the word on the street is the Oculus is going to be really, really, really amazingly cheap for having at least the capability of a cell phone built into it. But it's going to be pretty inexpensive. William, hi William. I looked at the work list and saw only coding jobs. Well, sometimes we do actually crowdsource other types of work. I think Chris had a job up there. Chris Collins had a job up there asking for help building some content in World. We'll definitely put more stuff up there as we get more interested people. But most of it is coding work right now, because that's kind of what we built it for. And then Doug was asking, minimum capacity device useful as a client. Well, like I said, my hope is that from a view-only perspective, HTML5 plus WebGL will work. And in that case, certainly a few years back on the device side will remain useful as clients. I don't think we'll go that far back, because we're continuing to see just a rapid drop in the cost of computing. I mean, I think we're in that exponential phase now where it really is true that the endpoint client devices are becoming almost free. So I doubt we'll try to make high fidelity work on much more than a 3 or 4 year old compute device. On the context of a Chromebook, I'm not really sure. I know the Chromebooks are pretty low-end devices, but I don't know enough specifics about their graphics capability to know whether it'd be an adequate client. But certainly HTML5 WebGL will be the right target platform for something like that. So thank you very much, everybody. Chris and I got to jump out into our meeting here. For an assigned client server, Doug, it would be a really low-end machine. Our target, our target on there is an assignment client will run on your phone. We already have that working, so that's kind of our vision for like the lowest end device for like interactive content would be an iOS client. So thank you very much, everybody, for having us. And Chris and I are going to rush off. And please do follow up with myself or with Chris in email. I'm Philip with 1L at highfidelity.io. Chris is the same thing, Chris. And we're it's great to have everybody here, and I'm so happy to see my couple of friends from Second Life that I recognize right off out there. And I'll work on getting a better avatar together. Maybe Amy, maybe you can make me one and send it over. All right, everybody. Thanks a lot. Talk to you all soon. Bye-bye.